It is Monday night, and this is the Physicist and Philosopher Hour. I am R. Wayne Steiger, the philosopher. My co-host is Dr. Claudia Albers, the physicist.
Hello.
How are you?
I'm fine, thank you, Wayne. But I hear you not so well, but
yeah, a little accident, and so I'm in that point of meditative pain control.
oh, that's not nice.
Anyway, this too shall pass. So, how are you? I hear it's getting cold in your part of the world.
It is. It's getting cold, and we had 3 days with no water.
3 days of no water.
Yeah.
That isn't fun.
That was not fun, believe me. And so they couldn't find the fault for 3 days. Eventually, they found it.
Wow.
Yeah. So now we just got water this afternoon. So.
Did you have water for Thanksgiving?
No. Oh, wait, we did. It stopped on Friday.
On Friday.
Mm.
Isn't it interesting, Claudia, how we're so dependent on, electricity, natural gas, water?
Yeah, I mean, if you can't have a shower, what do you do?
Yeah, you find out, huh? Now, was it
what do you do to flush the toilet?
Oh my goodness, there we go. The amenities that we take for granted.
Yes, and you start appreciating just being able to flush a toilet,
Boy, I'll tell you, absolutely. And I know that some may find this odd, but I learned a long time ago that if you're without water, like you said, you had 3 days. Yeah, I mean, you start roughing it, baby.
Oh, yeah.
Yeah. I mean, it's like, you can...
You cannot do dishes. It's so difficult to do anything if there's no water coming out of the tap.
No. And did you have to go and buy water, obviously?
Yeah, we had to go and buy. We bought lots of water.
I bet. See, I have 2 55-gallon drums for just that type of situation. I mean, like you said, potable water, number one, but just to flush toilets. Yeah. Well, okay. See, folks, this is what we're talking about. I just want to say.
And we had some stored water, but we went through it so quickly.
Yeah, so it's amazing. People, I don't think, realize that, most of us need at least a gallon of water just to drink. And if you're not drinking at least a gallon of water, I think that, they say that that's why most diseases and other things set in is because of dehydration.
That's right, yeah.
Yeah, it really is. Well, I'm glad you got water.
Yeah, I was so glad.
Yeah, it's like, oh, yeah, I've been without electricity.
I can do dishes.
I remember I was in a really good blizzard in St. Louis, and we were without electrical power for a week. And holy schmolies, you find out why winter is so dark. It's like when you don't have any light. It's like, okay, now.
Yes, I can imagine. I mean, oh my.
Well, I'm glad you're here. I'm glad the water is on, so the karma is changing. How's Scott doing?
Oh, he's well. He's in a meeting with some MFA members at the moment.
Good.
He's very busy and he's doing very well. Apparently, a lot of people are going to the website now and
excellent.
Very excited.
Excellent.
Yes,
and March for America, March on America.
Yes, March for America.
March for America. Hello, how is everyone? Peace. Well, good. Hello to all the moderators, and we got getting a full house in here. So, Claudia, as my sign says behind me, you and I were talking right before we went live. There was
11-11-8.
Yes, 11-11-18. So I want to pull up something for you So everyone can see this. This was taken, let me get over here. So right from Ben Davidson's Suspicious Observers. So everyone can see this graph. This was the event that happened. This is what they call a vertical compound waveform. It's a basically it's a, then they're calling it a wave. It's a seismic wave that was felt around the world, Claudia. There it is right there.
That is amazing.
Yeah,
you see, it's especially amazing because I hadn't looked at this, but I was thinking about what is coming for our planet, and what I see coming is really, really scary. Today, I haven't written anything about it, but I realized what's going on. And, you know, I wrote an article about really strong earthquakes, worldwide earthquakes, and I call it an ELE earthquake because it's an extinction level event earthquake, where the whole surface of the earth feels these waves going through it and superimposed on each other, because there will be multiple earthquakes at different points happening at the same time, and all due to the stellar cores connecting and causing electrical earthquakes. It could be due to the discharges, or it could be the Earth reacting to the presence of the stellar cores, and as they pull energy out. And then it would create these earthquakes at different points, creating the seismic waves, and the waves would then interfere with each other. So we get compounding of the seismic waves on the surface. And basically it would then trigger tsunamis. The tsunamis would be so huge that it would just wash over the land masses. So it could basically destroy most of the Earth's population.
Yeah, I mean,
that's why I call it an ELE earthquake, extinction level event.
Yeah.
Yeah, so this becomes possible when you start seeing what these stellar cores are doing, and especially now that you see that they are causing worldwide earthquakes where it's felt around the world at the same time. Then you start realizing that if you stretch this to its ultimate powerful end, you start getting earthquakes that can destroy most of the Earth's population. And then you have the weather events that are not that severe, but we have tornadoes. And I think they've shown us, because I think the powers that be know what's going to happen eventually. They put it in the movies. And if you watch certain movies like 2012, you see a whole group of tornadoes taking a whole city apart. That's becoming very possible. Tornadoes just everywhere, all around the world, and destroying cities.
It's happening. There's tornadoes now in parts of the northern hemisphere that have not been seen before. I pulled this up because fortunately I did not keep the file, and I'll pull it up and bring it up next time. But the word is out now. We know that this Madagascar was at one time part of the African continent. The rift, and I wish I'd had the pictures, Claudia, because I'll send them to you.
Yeah, I've heard about that. I haven't looked at the photographs. That the rift is getting larger.
It's canyons now.
Yeah, well, that I expected that, because they were starting to open just overnight within a few hours, and that can only accelerate. So it's only a matter of time before the ocean goes in there and separates the two parts of Africa.
They're saying 10 years.
Probably won't be long.
10 years. They're saying in less than 10 years that this.
Yeah, they're saying that, but it will keep accelerating, so it'll be even less than that.
Well, we're seeing it happen. And again, dramatic earth changes just taking place. So I wanted to bring this up. This is the NOAA website. This is where they came out with the latest climate report. And I wanted to show you, Claudia, what is happening in, this is what they do not send out to the public, at least what the mainstream media will show.
Mm-hmm.
But this is, you can see that something is going on. We're seeing drastic cooling. The report came out of New South Wales 2 days ago. They're about to hit summer, and they were hit with over a foot of snow. So they're trying to figure out what's going on. But as you could see over here in the Ukraine, Siberia is heating up like, it's just really odd. And you can see North America now having extreme cold.
Yes, I know. The extreme cold, I have figured out when it's not normal, it's that's due to the stellar core dust coming in. And if you get a sudden cold when you don't expect it, what they do is they actually make holes in the artificial greenhouse layer, which is made out of reflective particles, basically aluminum nanoparticles that they place in the upper atmosphere to create the greenhouse effect. So, but when a lot of dust comes in because of the stellar cores approaching the Earth, they punch a hole right through that layer. And then the radiation that the Earth is emitting and the radiation that these, whatever they are using, these laser projectors, say if they're UV, because the atmosphere absorbs UV radiation, but visible light will not be absorbed by the atmosphere, cannot heat the atmosphere, only ultraviolet, X-ray, and infrared. But when they punch a hole through it, what happens is the radiation leaves the atmosphere, and that means that it will cool, because that's radiation that won't be absorbed. It won't stay inside the atmosphere. So that's one of the reasons why we will be getting these very cold spells that sometimes happens in winter that weren't occurring before, like in India.
Yeah.
Nowadays it's getting extremely cold in winter. It never happened before. And so it's happening in North America as well, in Canada. But now it's not happening over the North Pole. And the reason for that is because of the ocean. The ocean is extremely warm because it's heating up from energy that's coming from the center of the Earth, from the core. So wherever there's ocean, then you will have this balancing of the cold and the heat because of all the heat coming off the ocean. It exchanges with the atmosphere, of course, and warms it up close to the surface.
Well, talking about that, it's interesting. In this article here, they bring out the fact of what's happening in Hawaii.
Mm-hmm.
That underneath these islands, what most people, and I did not realize this, was the amount of heat the ocean itself is absorbing from this fissure that has opened up, apparently, recharging these volcanoes.
Yeah, you see, it's not just happening here. Volcanoes are going off all over the bottom of the ocean, all over the place, because of what's happening inside of the Earth. It's heating up. The magma is expanding. So it's trying to find an opening to the surface. And it is finding at the volcanoes. And the oceans are littered with volcanoes.
Yes, they are.
And as these objects move through, they will open fissures at the bottom of the ocean, and more will come up.
That's what we're finding. And they tried to downplay it on the HRO's website that gives you the worldwide alert system. We found the anomaly last week. It lasted for 6 days. I haven't seen it today if they've not removed it. And even when you check the diagrams of it, the detail, we're finding a hot radioactive spot in Antarctica under the ice.
That's very interesting. That means that there's magma coming up.
It
That's
would seem
very,
something is amiss.
but it's coming up everywhere. I
Yes.
must say that even in places where there are no volcanoes right now, it's possible that one will form if there's enough magma pushing its way out and finding some weaknesses in the crust and the mantle through which it can get through.
So, Dr. Albers, this is the third article I have seen in the last 5 weeks. And the oddest places where this articles are turning up about the dimming sun.
Yes, they're trying to dim the sun to create global warming. But in the meantime, since 1998, they've been putting particles in the atmosphere to create an artificial greenhouse effect to keep heat within the atmosphere. So does this make any sense, Wayne?
I live in a world of insanity when I look outside my door.
I mean, it's really, since the end of 1997, they went global with this program. I wonder why. Why did they do it then? Because the sun was either dying or already dead then. That's why. Because if the sun is still shining, there's no need for an artificial greenhouse layer.
One would not think so, would they?
No, they are turning everything. I mean, they are saying things that are the exact opposite of what is happening and what they are doing.
It's nuts. I mean, it's nuts what they're doing to us. So to go along with this, well, we know that this is going, the spikes and the increase, Claudia, is these numbers will be updated soon. This is getting to be.
The problem is that the Earth, we already wrote about that, has become a source of cosmic rays. Yeah. Why? Because the objects are pulling energy out of the core of the Earth. And what we're going to end up with is an increase in fission happening in the core, an increase in acceleration of particles. And so they're going to come out.
Do you know what else we're seeing? This is, my wife and I were talking about this. The young men today, those that are entering puberty, those that are as old as their mid-20s, their sperm count has decreased by nearly 40%. This is not good news for our species. And they don't know what they are attributing to this to, is that they think it's environmental, obviously. But here's the problem. The young boys and young men, their sperm counts are decreasing, and the young girls, the fallopian tubes of their eggs are, I think, as they call the membrane around it, is becoming weaker and weaker.
Yes, that has to do with a lot. There are a lot of factors. First of all,
understand.
I think the powers that be have worked hard to get that done because they want to decrease the population. So they put place things in the environment to cause that, including in the chemtrails. And so chemicals will do that to your body. Fluoride in the water interferes with your endocrine system and how it functions, because all endocrine cells need iodine, and fluoride blocks the function of iodine in the cells. So that's a major thing. It's fluoride in everything.
Well, it's
not the only thing. There are many other factors. There's the radiation coming off Fukushima. There's radiation in the food we're eating because there's radiation falling on the ground. It's coming right over from Fukushima all the time.
I agree.
So the northern hemisphere is filling up with radiation from Fukushima. Eventually, we'll get to the southern hemisphere, but it will be the northern hemisphere.
In the meantime, we're seeing, again, I feel bad for the younger generations. I mean, my generation, we didn't have this to worry about. You know, we so when we're talking about the human race, Claudia, this is an article I had discussed today on my channel. My wife and I literally, before I came live, were talking about this. This is the study that came out of MIT. And Claudia, I'm going to send this to you. This is probably the most disturbing news for our species that I told my audience today, this is the end of the Homo sapiens sapiens.
Yeah, it is. I saw an article saying that China has created the perfect human being. Actually, what they have created is an artificial human being. It's not a human being anymore.
This is, folks, they changed the DNA.
That's not right.
They changed the DNA, Claudia.
It's a genetically modified human being. We
Yes.
know what happens with genetically modified anything. They don't work properly.
So my wife and I were just talking, and I said, all right, let's think. What's the end game here? This is China. This is a totalitarian regime. And she looked at me at the same time. She says, they're going to make super soldiers.
Oh, yes, that's, of course.
This is what we can expect.
Mm-hmm.
Claudia, I don't know if people understand how serious this has gotten. I said this earlier. If you want to use the metaphor, we just became gods.
Yeah, well,
I'm not saying that in the way of the divinity. I'm saying that we're now messing with the very life forces itself.
Yeah, the thing is, what we are trying to do is create superior human beings who will then destroy real human beings.
Yes, ma'am. Yes.
That's what's happening, because then they'll be superior and say, oh, well, now we don't need you.
Exactly.
And we don't want you.
We don't want you. Claudia, this is nuts.
Yes, it sounds like human beings are trying to destroy themselves, but it's not human beings trying to destroy themselves. It's the spirit that's acting through human beings that's trying to destroy human beings.
Well, they just took a giant leap on this one. So getting back to the dying sun, there is a subscriber. You'll see him all the time. His name is Plunder. I wanted to show you what he did, Claudia. He went out and can you see that?
Mm-hmm.
Okay. Let me see that I get this down. You're going to love his work.
Mm-hmm.
He has shown, going by core 2 images here, there's a background lighting source greater than the sun. And you can see it's taking place. Excuse me, I just moved my mouse, but he went through hundreds and hundreds of frames, Claudia, and compiled them in this video here, and clearly shows that there is something very bright outside there. So I wanted to show this to you because I know you.
Yeah, I have noticed that there are very bright clouds moving through the outer corona sometimes. I think that is to do with all the debris that's there. And this debris will emit light because of...
Wait a minute, there it was, right there.
Okay.
Let me go back a couple frames.
There are, of course, objects that are much larger than the sun near it. We've seen them many times. Some of these stellar cores are much larger than the sun.
All right, see how dark we have it here, as it should be? It should. I always thought that these are. Now watch what happens here. And actually the sun is gravitated towards it, and you'll see it in this inverted frame that he has. There it is. It's starting to come in now. Whatever it is back there, it's, and you can see it. It's the faintest glow. Anyway, I thought it was some fabulous work. We got great subscribers. Look at that. There, that was one of the best intensities of where the field comes in.
Yeah, the thing is, the corona is not even supposed to be dark like that. They say it is, but it's not. There's supposed to be light coming from all sides of the sun, enough to illuminate the corona so that it's not black. It's not supposed to be black.
Well, here what we're showing, what he was showing is that there
are things right at the edge of the outer corona. I've seen that many times in some images, yes.
Well,
and I've seen these very bright clouds sometimes move through. And all these spots, these are not background stars. These are actually debris moving through, brighter than the background. But basically, the sun, the whole inner corona and outer corona, has become filled with debris. Don't forget, these debris fields have been coming in for thousands of years. And we thought that whenever there's a sun diving comet, and there's just been another one recently, whatever happens to them is they just burn up. In other words, they become, I thought that as well. That's what we were taught. That the sun is so hot, so they will vaporize. Nothing will be left. But that's not what's happening.
No.
All this debris and all these objects are there. They accumulate in the sun's corona, and they've been accumulating for thousands of years.
Maybe longer than that. I don't know. I agree with you. He did some great work here. And Louder,
very interesting.
He did it documented well. There's obviously a rotation cycle that's coming out here on the edges. And you can see how our sun and through these flares are attracted to whatever the heck this is back here, Claudia. I don't know what it is, but
there's probably something in orbit around the sun. I mean, we've seen that.
Yeah.
That must be, these objects rotate. They orbit the sun. They have a very strange orbit. I've described it before, where they have a very long orbit. And then they come in, they do a very close orbit. And even in that close orbit, they sometimes come right into the sun's corona, make a connection, sometimes remain stationary for days in that position, and then eventually move out into another orbit. But they are orbiting.
They are. So I did a video earlier, and Claudia, and I'm just going to go ahead and stop sharing this, and we'll get, because I wanted to get to your papers. We have definitely, well, all I can say is that I think our solar system has changed. It's changing dramatically. I did not know that it's official. Neptune is no longer in its normal orbit. Did you know that?
I didn't know. What I have learned about is that all the planets have heated up, have increased their energy output. I expected that. Yeah. Because the stellar cores would have affected all of them in similar ways, including the sun. The sun put out a whole lot of energy for thousands of years before it was no longer able to and started losing the corona. I mean, it's still putting out energy, but it does without a corona. It can't emit light. So that's the problem.
I went through, and every one of the planets, by the way, this is Mercury in the full light. Isn't that a beautiful planet?
It is beautiful, but that's false color.
Yeah, it's the full spectrum is what they did on this one. And
because it actually looks a lot like the moon. It's just gray.
Yeah, this is what we see.
Yeah.
Yeah. So Venus, it's now slowing dramatically. It continues to slow the rotation, but the internal winds are speeding up.
Yeah, that's very strange. If a planet It would mean that its gravitational field is changing.
I'll send you the white paper on this one. The math is over my head.
Yeah.
You would understand it better than I would, but
Oh, okay. Rotation slowing, winds speeding up.
yep.
It's very interesting. I didn't know about that.
It's in fact the last observation. This planet, if it continues the way it's going to go, Claudia, it's weird. So we know about the Earth changes. Mars, if Earth had the same increase in heat that Mars had, we'd be experiencing temperatures 50 to 60 degrees above normal. This is what's happening on Mars.
I think we may still do so. Don't forget the temperatures in the middle of Australia have skyrocketed over the last few years. We've seen temperatures in India and Australia that have never been recorded on this planet before.
Getting hot. Jupiter, this one I was telling you before we went on, it's changed radio frequencies. That's bizarre.
Yeah, no, that I would expect, because Jupiter is being affected by the stellar cores in the same way that the sun was. So its emission, because it's a small star, Jupiter's a small star, would be affected just like the sun's emission would be affected. So of course, whatever radiation it emits, that would change.
Saturn, this superstorm was, let me get this right. It was 30 years earlier and lasted and is still lasting, which is another 20 years beyond the normalcy. So it's changed the entire planet, they're saying.
Yeah, well, that would be expected as well, because when you have stellar core dust entering the atmosphere of a planet, it draws energy. So there's more energy coming from the inside of the planet. So whatever systems that energy is driving, it's going to speed them up and increase the severity of whatever storms that planet has in it.
I never have understood how do you get
Saturn is actually a star as well.
Thank you. Because how do you get a hexagram at your pole?
Yeah, that is very strange. That probably has to do with the symmetry of gravity, which we still don't know a lot about, but it is a wave. I know it's a wave. And if it's a wave, then it can have a strange wave-like patterns to it. And obviously, this is what we're seeing here.
Neptune. I think this is a beautiful planet, but this is a storm we've never seen now. This storm, by the way, is 3 times the size of Earth. Neptune is changing and is now officially out of its orbit.
That's very interesting.
Something's happening out there, Claudia. I don't know what.
Yeah, I mean, if the planets are starting to move out of their orbits, that could be that the sun's gravitational field is changing. I mean, I would expect Neptune to change as well, because if Saturn is a star, Neptune is at least close to being a star. It's a large planet.
Yeah.
There is Uranus. All these gas giants are probably more stars than planets.
This is that storm I was telling you in the Northern Hemisphere. Unprecedented. This is the 3 different band wavelengths that we see it. There it is there. And this thing just showed up within the last decade, Claudia.
Yeah, I mean, the same thing as with Saturn. We get stronger storms because the Planet X system, stellar cores, are comets. That's what they are. They are comets. They are depleted in energy, so they draw energy from inside the planets and the stars in the solar system. And they're going to activate them. Everything that's happening on them will get more severe, more dramatic.
And this graph here shows what's happening on both of these planets. Their poles,
I'm actually surprised that the atmospheres of these planets are not being pulled apart, because that's what they do. That's what these objects will do. They will destroy the atmospheres of all the planets.
Yeah, I didn't know, for instance, I didn't know that Neptune had bands on it. Uranus is flipped. I mean, this is it's flipped again.
Hmm.
This is planet, whatever is perturbating its orbit out there is affecting Neptune as well. But this is the one that I just found totally bizarre.
That's very
And
strange.
look at that.
Superstorms,
Yep.
yes.
Yep.
Yeah, you're going to get storms in all the atmospheres. The objects are going to draw the atmosphere of the planets. Obviously, that they don't want us to know about, but that's what they do. They pull the atmosphere. So eventually, the Earth will lose its atmosphere and its oceans.
You know,
Probably slowly, but
I think it's happening. And I don't understand, how is this possible? It's the dynamics I understand of
okay. So
rotation.
they saying the equator flipped.
Yeah, this is and here's the recent pictures coming from there.
Ah, so it had a crustal displacement.
Yeah, that's just weird. I mean, but this is what's happening. And then Pluto, we're
Still
finding.
warming up, probably.
Yes, thank you. That's what's happening.
That's exactly what I'd expect to hear.
Yeah, there it is.
Yeah, because again, they're pulling energy from the core, so it will warm up. Yeah, that's exactly what I would expect.
So I guess the question I have is, they say that we've been hit with this, I don't know what it is, energy field. But I guess the question is,
they're always talking about these waves of energy. Do you know what the waves of energy are? It's another one of the comets arriving with a huge debris field. That's what it is.
And speaking of which,
and affecting the solar system. You see why the Earth and the planets are getting more and more affected is because the sun is so weak. It's not supplying the electrons these objects are depleted in. So where are they going? They're going where there's still electrons, the planets.
well, I thought this would be a perfect segue into your papers.
Okay. Yeah, so this one is about is dark matter engulfing the sun and the earth? Because I read an article about it. And so I started thinking about it, dark matter. And you're the one who mentioned dark matter last week.
Mm-hmm.
And to tell you the truth, I don't like the term dark matter.
I don't know what it is.
Because I know what they use it for. And it is to explain things in a way that has been totally falsified. And because they are using redshift to say that, to measure velocity, to estimate the velocity. Oh, you got the book there. Yeah.
Yes, I do.
So, but there is something about it that sounds a little bit like disclosure about what is actually happening, and that is that the solar system is being filled with all this debris, and this debris is absorbing energy to the point that the sun has lost the ability to replenish its electrons. That's why it lost its corona, and that's what we see here in these two images. How the sun has for years been losing its corona. Okay, so that's there, it's documented. It's probably much worse than it looks like in these images, because I actually believe the images they're showing us are much older than the timestamps they've placed on them. But, and there was one article that I wrote about that. So these images show the sun's dark. Now, dark matter is mass that does not emit light and is weakly interacting. So basically, we cannot know it's there. We should be able to determine that it's there through its gravitational interaction with other matter. But it's been hypothesized. There is no evidence that it actually exists. But this is where it comes from, this diagram that shows how the velocity of stars in a galaxy changes with radius from the center of the galaxy. And it's supposed to be like the red line That is, it's supposed to decrease with distance from the center. But it seems to be that you don't get that, you just get a straight line. Now, the reason why you get a straight line is because they are determining the speeds from the redshift, from the spectrum of the stars and the redshift of that spectrum. And they are interpreting redshift as recessional velocity. So they say they're looking at different parts of a galaxy, looking at the redshift for those different parts and say, okay, that part's moving at that speed because the redshift is the same as there, it's the same as there, it's the same as there. So basically the speed is the same as we move away from the center of the galaxy, and that's not supposed to be possible. So what do they say then is, okay, we have all this matter beyond the edge of the galaxy that we don't see. That should explain it. Actually, it doesn't. Let's remain with that diagram first. So galaxies, our galaxy is only about 16 kilopascals in radius. You can see where 16 is, between the 10 and the 20. Average galaxies go up to 30. Okay, and those are large galaxies. Very few galaxies go beyond 30. So even if we have extended the edge of the galaxy with matter that we do not see, we should eventually see a drop-off in the speeds. And that's not there. You see it goes up all the way to 50, and it's still a straight line. So even though they have come up with the idea of dark matter, it still doesn't explain what is being observed here. And the reason for that is because they have incorrectly interpreted redshift as velocity. And as the book that you showed shows, Alton Arp showed that redshift is intrinsic. It's an intrinsic property of matter, and it has to do with the age of the object. Because young object, and that I immediately interpreted as energy, because a young object is high in energy, and that's photon energy inside its particles. And an older object has less energy. A dying star will have less energy. So what this shows is that because the redshift is the same all across the galaxy, it means that all the stars are of the same age. That's what it shows. It doesn't mean they're moving at the same speed. It means they're all the same age. They all have the same energy. They were all formed at the same time. When you correctly interpret redshift as it should be interpreted, that is the conclusion. That's what that data shows. But they will not accept it because it's a religion to believe that redshift is only connected to recessional velocity.
Interesting.
Yeah. But it is still, talking about dark matter, because stellar cores are basically dark matter. We don't see them outside of the solar system because when they come into the solar system, they start absorbing matter from the solar system. And then that matter emits light because the objects are absorbing energy from it. Otherwise, outside the solar system, we cannot see them. They are basically dark matter. And they are, in a way, they are not low interacting because of their very low energy. They're very strong absorbers. But they have low gravity, low gravitational fields. They have low gravitational influence because they are low in energy. So there are some similarities between dark matter and stellar cores. So saying that the sun and the earth is getting engulfed by dark matter is, in a way, disclosure about what's actually happening. Because it's stellar core matter that has engulfed the sun and destroyed it, its ability to emit light, and is now engulfing the earth and the rest of the planets in the solar system.
I believe that. They're saying as much.
Yeah, they tell the truth in hidden ways. They don't expect us to understand that they are telling us the truth. That's what it is, but they still tell us the truth.
So I always love this picture of the bulge of the Milky Way.
Yes. Yeah, I was just explaining how large it is.
Yeah.
It is 52,000 light years in radius, and that's 16 kiloparsecs. And where one parsec is 3.26 light years.
That's
It's
big.
huge. It's huge. So that
mean,
means it takes light 52,000 years to move from the center to the edge.
Now, the question I have, do these two edges ever see each other? I mean, could they even know each other?
It takes 104,000 years.
Yeah, light years, right?
Light, yeah, it takes 100. Well, if we can see a star, if we on a star at one edge and we want to see another star at the other edge, and if we are able to see it, not that we would be able to through the bulge, but if we were, that star would be 104,000 years behind us. So we would see the light that left that star 104,000 years ago.
Yeah, talk about long distance relationships.
Yeah.
Okay. I mean, so the core of the Milky Way, as I understand it, we can't really see the core from where we are.
No, apparently there's a lot of
Dust?
matter
Around
the core, and we actually saw that photograph of what the core looks like. The core has broken up into pieces, and it's spread out all over that bulge, and each of those pieces are ejecting matter, and basically they're ejecting matter in a fluid state, and then that matter is condensing into globular clusters of stars. So you always see globular clusters above and below the bulge. And again, I put in that diagram that explains the ARP controversy, and that is that you cannot explain redshift as recessional velocity, because that would mean that the objects would not be together like they are here. So you have Markarian 205, which is a redshift of 0.07, and that galaxy NGC 4319 that has a redshift of 0.006. And the way that redshift is interpreted as recessional velocity and therefore distance would mean that the Markarian 205, which is a quasar, would be much further away from Earth than the galaxy. But yet they are connected by a luminous bridge, by matter. You can clearly see the connection. Now, excuse me, but two objects have to be at the same distance from Earth in order to be connected. So there's no way that redshift can be interpreted as distance or even as recessional velocity. It is impossible in the face of this evidence. And this is not the only one. There is much, much more in that book seeing red. But do you see how astrophysicists are blind? They have blinded themselves to clear observations. And it's not just one. Just one is enough to falsify the Big Bang model and this interpretation of redshift. But there isn't just one. There are so many. There are hundreds of observations.
And, you know, Halton Arp, he, like I said, the math in this one here, I don't even pretend to know it. But even a novice can read this.
Basically, all you have to do is know how to look at a picture, and use logic to interpret what it's telling you. Look at that. There's a quasar connected to a galaxy. Quasars are supposed to be at the outer edge of the universe because of their very high redshift. But they're in the same place. They can only be in the same place if they are connected.
Claudia, and maybe we can talk about this next week as well, is about the Blazar, TXS 0506, that they're saying, I'll send you the article on it. They're saying it's already gone supernova and it's in our quadrant.
Okay. Supernovas are not a star dying, though. They do occur. It's a star being born, or stars fissioning. So basically what happens is there's this planetary nebula that forms around the star, and they say that's because of the supernova. No, it's not. The sun has nebula clouds as well. It's like a new star was born. And the first thing that it does is it creates nebula clouds around it. And it can only do that when it has a lot of energy. Stars with very little energy cannot produce a solar wind, much less populate the nebula clouds. Basically, it's like a galaxy, but it's on a small scale, a star populating its area of influence.
Now they say that this is that, and I don't know how much people are reading into this, but, and again, we can maybe put that for next week, but they're saying that if this is a case, that we could be potentially in the kill zone for a gamma ray hit.
Yeah, I mean, there will be, there could be gamma rays being emitted, strong gamma rays. Young stars, especially when they are born, are likely to have very strong gamma ray emissions, but that comes from the fissioning of unstable nuclei in it, and it comes from the matter creation events that will occur when its electric field starts out and is extremely strong.
Would dark matter have any reaction to that? I mean, if this blazar is doing what they're saying it's already done? In fact,
no,
I didn't even know what a blazar was.
It's low interacting, so it's not going to interact with it. But the thing is, our solar system is surrounded by all this dust that comes from these dead stars.
One of our viewers asked, could it be that we're still witnessing the collision of one galaxy with another?
I think it's actually unlikely that galaxies collide. I mean, it's not impossible, but I think what they are describing as collisions are actually galaxies separating. Because everything in the universe, you know, they reverse the whole of physics. Whenever they say a star is dying, it's actually being born. And when it's an old star, they say it's a young star. That they often reverse things because of the way they interpret things, like I said with Richard.
And who'd have thought that hermetics would have applied here? Because you see, that's probably one of the first rules, is that all truths are half lies.
Ah, well, they are, because the way the planet is run on lies.
Yeah, it is. You have a couple of others on here, Claudia. You want us to continue on this one?
Which one was that? Sorry, I forgot. Yeah, is this the one about the dark matter?
Yeah, because I have the other one up here.
I basically finished explaining everything there is to it.
I like this one. You said the galactic structure manifests as the wave nature of gravity. This is, I found interesting.
Yeah, yeah, but people were asking me questions. I think I didn't explain things properly. And that is basically, the wave is like a flattened gravitational vortex, where you have the center of the galaxy, the bulge is creating the gravitational wave. That would be like the object, the stellar core at the top and the gravitational vortex at the bottom. But with the galaxy, it's flattened so that the wave is around it. But it is a wave because it has high density rings and low density rings. That's exactly like the wave that we see occurring on the ocean that the stellar cores are producing. That's why they create high tides and low tides. The low tide points are where we're going to get ocean recession events. And usually we very likely only to get one maximum and the hollow in the center and perhaps another minimum at the edges because the wave dissipates too fast when you move away from the center. But with galaxies, you get multiple rings.
Yeah, and gravity is in waves, right?
Yeah, basically, gravity is a wave because what causes gravity is light. Yeah. And what powers gravity, first of all, matter comes from photons, and photons are the energy inside the particles that generates the gravitational field. So because light is a wave, so that means that gravity is a wave as well because it's light as well.
It would emulate it, yeah. I see that.
Yeah, but the thing is, you only see the wave nature of light when there are a lot of photons together. They're moving together as a fluid. And the galaxy is a fluid as well because there are so many stars. When you have a large area of material and the particles inside that material very small compared with the amount of matter you have, basically what you have is a fluid. So the stars are a fluid, and therefore the wave nature manifests as the density rings. Now here I show what happens with a stellar core as it approaches the surface of the ocean. And so you get the highs and the lows. They won't be as high as I show them here, I don't think. But I just wanted to make sure that you could see that you get the tidal bulges and the hollows in between. And then as the stellar core comes closer and closer, the region that is being affected, because this is actually a tidal wave, so only the region right below the stellar core will be affected. It interacts with the ocean. And then the bulges go up. And then eventually the stellar core gets to a certain distance where it's so close where its contact is made with the tidal bulges. And that's when the gravitational vortex forms. And it connects the two objects.
Cool. That makes sense to me.
Yeah, but that's because gravity is a wave. That's why it does things like that. And so because gravity is a wave, it manifests as a wave whenever we're dealing with a fluid. And the fluid is the ocean that's made up of a lot of water molecules.
Has a lot of effect up here on probably in our magnetic poles as well.
Yeah. So with the galaxy is basically a liquid as well because it's a lot of material made out of pieces that are small compared with the amount. So basically each star is like a particle in a fluid or in a liquid.
Yeah.
So the wave manifests, the wave nature of gravity manifests in the galaxy. And that's why you can clearly see the rings there. You get high density rings and low density rings between the high density rings. That's a wave.
It looks like a pebble being dropped in a brook.
Yes, indeed.
That's what it looks like.
Yeah, exactly. That's a very good observation.
Thank you. I study. So, okay, then here we go.
Yeah, and there it is. This is actually the Milky Way galaxy, and I mean it's not a real picture. It shows the structure of the Milky Way galaxy through observations that have been done, but you can see the ring structure there as well. So the Milky Way also has rings of high density and low density. So it's a wave as well.
What's your thought, Claudia, that when I was a child, and I know our science has gotten better as we've gotten better instrumentation, But growing up in my astronomy classes, we always thought we were like out on the third end of the Sagittarius spiral.
Mm-hmm.
And more evidence is showing that we're a lot closer to the core, the center, than what we thought we were.
Yeah, to tell you the truth, I don't know exactly where we are. Apparently, they believe we are a lot closer.
What would give them the belief of that?
I also remember saying that we in one of the outer arms, but the whole structure of the Milky Way has changed as well. Look how different it is. I mean, there are a lot more rings there than I saw as a child when I studied what our galaxy looked like. Because basically, we didn't have as good observation instruments as we do now. Perhaps it's that. So we were seeing galaxies out there, and we thought our galaxy looked exactly the same as these ones. So we had them with a lot fewer arms, a lot fewer high-density rings, basically.
Yeah.
And now that all that's changed, we're seeing them. Of course, unless we actually leave our galaxy and observe it from far away, we won't know for sure.
And they say that the movement of our galaxy is, and I think it was 1/16 the speed of light. But as you were talking, I'm looking at this and I'm thinking to myself, a galaxy is generating a lot of energy, isn't it? A lot of centrifugal energy, it would seem like, as well.
The energy will be mainly generated by the core of the galaxy. So the core of the galaxy would be very dense and very large. It would have a lot of unstable nuclei to fission. And fissioning, all it does is it transforms mass into photon energy. So the larger the objects, and the center of a galaxy would be extremely large, extremely dense, it would be able to generate a lot of energy. So it would generate a very strong gravitational field, much stronger than anything a star would be capable of. And that's what powers the whole galaxy, because it's the core of the galaxy that has matter creation events that ejects either other galaxies, the youngest galaxies, or ejecting matter that condenses into quasars and then become galaxies in their own right. Whilst the older galaxies like our own are ejecting material that becomes a globular cluster. So it's a small version of, a galaxy. But there's a lot of energy being generated there, yes.
I often, as you were talking again, my mind was thinking, I wonder if a spirit could walk through the galactic core.
Yes, I'm sure.
That would be far out.
Yeah, I'm not sure I would want to walk through the center of it, but I definitely would like to see it.
I would definitely like to be there as well.
Yeah.
So, all right. So we get on to because, these are the questions we don't ask ourselves. We look at this and we say, well, that's pretty. That's where we live. But most people don't even have a clue as to what this is really saying.
Mm. No. Well, a lot of astrophysicists don't even ask them the questions because they don't like the answers.
As you have well found out, haven't you?
Yeah, and here I explain why things rotate. And they rotate because the gravitational interaction, like I said, is a wave. And it has a hollow. It has a minimum in the center. And the hollow means that if matter gets too close to the center of a forming object, it's pushed outwards. And when it's pushed outwards, it will start rotating. It will move around. So that's why objects start rotating from the moment they form. And here I also explain why everything will rotate in the universe. Because if you want one object by itself will move in a straight line. But the moment they start combining into groups of 2 or 3, then they will only move in a straight line if they're moving at exactly the same speed. The moment one is moving faster than the other, when they come together, the group will rotate around some axis.
You know, as you were talking, so Claudia, I can see this now, because gravity is an elusive construct. I'll admit it for myself. I continue to think about it, but I'm learning more and more it starts at the quantum. It starts down at, as you pointed out here, at the nuclei of the element itself.
Mm-hmm.
And so I always like what it says in the book of Proverbs, you know, it's the least that will rule the greatest. And here is how I interpret that, is that I'm looking at protons, electrons, neutrons,
Mm-hmm.
that they in their own structure begin to dictate what gravity becomes.
That's right. Absolutely.
You see, your teaching works.
Wonderful. I'm glad.
You know, and
Yeah.
so when you do diagrams like this, it helps explain it on the macro level.
Mm-hmm. Wonderful.
Yeah, I mean,
that's why I draw these diagrams, trying to explain these concepts to people.
we see, if I'm getting it, you can bet the rest of them too are. So
That's wonderful.
So this is fantastic. So okay, so then it gets
and
down.
then I explained that the moment you have charged particles rotating, you are going to get a magnetic field. The electric field gets set up whether charged particles are moving or not, but the magnetic field requires that they move. But as we know, everything is rotating. So the moment you have a rotating object, it's going to get a magnetic field. That's why galaxies will have magnetic fields. All objects will have magnetic fields because of the movement of charged particles.
It again, from the smallest to the greatest.
Yeah, it starts with the atom. It actually starts with the particles themselves, the protons and the electrons, and the interactions between them. You can build up everything that happens in the universe from particles themselves. And the interactions come from the photon when the particles emerge. Without the particles, there are no interactions.
Folks, this is why we have one of the best. All right, I have another one up here. Mm-hmm. This one I wanted to pull up here because I thought this one was great. So
yeah, so I suddenly looked at this photograph and I started thinking, but wait a minute, when did they find out what was happening to the sun? And I came across this website in Germany because the LASCO C1 chronograph was put together by the Max Planck Institute in Germany. So there's a website in Germany that still puts out these images from LASCO C1.
Really?
Now, the problem is the SOHO spacecraft was launched in 1995. But some of the images, there's a whole video with 657 frames with images where the timestamp on them is from 1986.
Well, how can that be?
Well, they say it's from 1996, but clearly the timestamp says 1986.
You get up and here you go.
Remember, Wayne, it's disclosure. They tell us the truth all the time, but don't expect us to actually understand that they are telling us the truth. So if you look at that timestamp at the year, it has a 1 and a 9. Does that look like another 9 after that 9?
Well, we're going to take a good peek at it. Look at that. It says 86.
Exactly. It's an 8. It's clearly an 8. It's not a 9. You can see it's right next to the 9. They did this on purpose. It's right next to the 9. You can clearly see the shape of that 8 is different from a 9. There's no way that's a 9. That's an 8. It's 1986.
Yeah. Huh. Now, you know something else I noticed on this, Claudia? When did the corona get this large? I mean, now this shows you
Yeah.
the difference of what we see today. We barely even see a corona.
Yeah, I mean, it's hard to compare the images because these are visible light from a chronograph that was different from the Cord 2 and Alaska C2 and C3.
Yeah.
So I don't actually try and compare. What I say is look at what's there. And they saw this. They must have seen it in 1986. But it's worse than that. They knew this way before 1986. And I show the evidence how I know that they knew. You see, look at all the stuff in the sun's corona. You can see these are objects, these are debris. This is not the corona. The corona is gaseous. It forms a continuous fluid-like material around the sun. It's not in little spots.
You know, what's also very odd. So the sun is generating 360 degrees. Even here, we see the absence. It's almost like a cap is on top of the
Yeah, the
freaking
sun by 1986 was strongly affected already. That's what I see in this image. There was so much debris, and all this debris is absorbing energy from the sun. It's absorbing electrons and it's absorbing photons from the sun. And the sun will generate lots and lots of energy in order to make up for the energy that it's losing to all this dead matter. It's dead matter. It's energy depleted. It's absorbing all its energy. This is what the sun looked like in 1986.
And
now you start to understand why I think the images we are getting, this image may actually have been from 1986. The images we are seeing now from 2018 may have been from 1998 or even earlier. I don't know. But they're not showing us current images. The sun was strongly affected in 1986.
I'm just shocked as I'm looking at this, and look at this. This is what now. So I've blown this up to 1600%, but this is what I'm trying to get at.
Look at that. Exactly. You can clearly see.
What the freak is going on there?
It's full of debris. It's absolutely full of it.
Look at, you can see the obfuscation of the light itself.
Yeah.
This is the sun, right?
This is why they put out the story that something went wrong with LASCO C1, because you just could see too much.
Look at this.
And this is, if they don't want us to see images from a certain spacecraft, then they invent some kind of accident that it has.
Look, now you see, this is what I don't get. Look at this.
I know.
Wait a minute. I'll look at this. This is okay.
You can go to the website and download all 647 frames or something. But there is a particular one that I had that was not part of that. They had removed. I'll show that. And there I blow up that image to show it is an 8 there. It's definitely an 8.
It's an 8. It's clearly
definitely an 8. All these images have 1986 on them.
So the TCB, which is the time code reading, there you go. Wow.
Yeah, this is the image that was not part of those frames. And you can actually see a discharge between objects there. You can see that straight line.
Yeah.
You can see there were objects there, and there were plasma discharges between them.
Look at the objects there.
Yeah, it's just unbelievable how the inner corona, the outer corona is just full of material.
Yeah, I want to get there and look at that. That's that streak we were looking at.
Yeah, and you see, when they launched the spacecraft, and they may have launched the one that this image either doesn't come from SOHO, the spacecraft that was launched in 1995 comes from another one, or they actually launched this spacecraft in the 1980s. They just didn't tell anybody. And but there was some spacecraft that were being launched in the 1980s. So
wow,
it's
there's a
either one
lot
of the
of
two.
debris through here. Okay, this is fascinating.
It is.
This one is
And then,
really,
you know, I explain again what these objects would look like, because by the time they launched this spacecraft with this instrument on it, they already knew that these objects were there, because they purposely defocused it and misaligned it so that these objects looked like that. They did that on purpose. They knew these objects were there. They didn't want it to be obvious.
mm, 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 mm.
So they knew. They already knew by then.
They knew.
Yeah.
Oh, Claudia.
And then I go through, yeah, look at that.
Yeah. Okay.
And then I go through what had been launched. And the first satellite was not launched in 1957 by Russia. It was followed in January of 1958 by the US, launched their first. And then there was lots of satellites being launched in the 1970s. Let me see there, because I can't quite remember the dates.
Okay.
So IC-3, it was the first satellite that was launched into the L1 position, which places it directly between the sun and the earth. So there I just explained that SOHO was launched in 1995. So these images either do not come from SOHO, they come from an earlier spacecraft, or SOHO was launched much earlier than they've told us.
Would not surprise me at all. I mean, think about it. The classic misdirection. You've got a bird up there, but that bird's been up there for a decade. You've gotten all your telemetry data that you needed, and now you let the masses get a peek of it, and we pick up the crumbs and try to figure out what the hell's going on.
Yeah.
Yeah.
And then the other thing was, you see, those images that we saw are actually composite images. The occulter is replaced with magnetic data on the sun's magnetic field that comes from the Wilcox Observatory, Solar Observatory. And they started collecting data on the sun's magnetic field in 1975. Now, they either found out then there was something going on with the sun, or they found out before through some other data there was something wrong with the sun. And then they started collecting this. Because these two authors, Penn, if we move down.
Okay.
Penn and Livingston and Penn. So let's look back at that graph there. They used whatever data they could find, and that was data from, I think, 1996 and 2009, or at least they believe that's when the data came from. It was probably much earlier, because the sun was either dead already by 2009, or it was very close. And so it would have been much weaker than this. They found that the sun's magnetic field associated with sunspots was declining sharply by 50 Gauss per year right through the cycle, so independently of the solar cycle. So that would show that there was something very wrong with the sun. So they probably found this out either before 1975 or shortly after 1975.
Wow.
So they knew there was something wrong with the sun. Now they needed to figure out why. And soon after that, well, we have evidence that the first probe to be sent to a comet was in 1985. And it was the same spacecraft that was launched into that L1 position, which we see there. It's right between the sun and the earth. So the satellite, or the spacecraft, it's a spacecraft, it doesn't orbit the earth. It orbits the sun, but it moves at a rate so that it's always between the sun and the earth. And so it was the same satellite, IC-3. IC stands for International Sun and Earth explorer. And it was launched into the L1 position, I think 1977 or something like that. And then it was used in 1985 to make this first encounter with a comet. Now, it wasn't designed for it. They hurriedly sent it to a comet in 1985. Why? Because they must have found out the comets were doing this to the sun. And then after that, they must have, well, there was Halley's Comet came through in 1986, and there was a whole lot of probes sent by different nations to the comets to observe what the comets were doing. So there was a whole lot of activity. They either used they either made it purposely popular for the Earth's population, Halley's Comet coming back after 96 years, or 76 years, or they used that in order to be able to send all these probes to comets. But they were trying to find out what comets were and what they were doing with the sun. So they must have known then by 1985 it was the comets.
Interesting. I remember Hale-Bopp when it came through. I thought Hale-Bopp was brighter than Halley's.
Yeah, it must have been huge. Well, Halley's Comet was not actually a stellar core. It was a piece of debris from a stellar core. I don't know how large it was. It could have been much larger than it seemed, but it was not a stellar core because of the shape. A stellar core is always spherical. Hale-Bopp, I think, may have been spherical, was a stellar core.
It was huge. I lived in California when Hale-Bopp came through, and I've never seen that comet was huge. And, it had the split tail.
Yeah.
But, yeah. Wow. This has been an amazing journey, Claudia.
Yeah.
So where do we end up on this?
So this means that they knew by 1985 what was going on. And I think that's when they started making the plans. What I've discovered now through doing all this, but they must have discovered all this in the 1980s. Right?
Had to have.
But the final conclusion is we cannot survive on the surface of this planet for much longer. This material that has destroyed the sun will basically destroy our atmosphere and the surface of this planet. And this is, I think, the reason why they built all these cities deep underground.
I'm going to stop on this paper here. This is, Claudia, you just did great. This is fabulous. You heard what Elon Musk said over the weekend. He said, I am going to Mars. I mean, the elites went off this planet.
Yeah, even if they manage to get to Mars at all, because with all this material in the solar system, navigating to Mars is not easy. If they do, they will have to build a city underground as well. They will not be able to survive on the surface of Mars, just like they will not be able to survive on the surface of the Earth.
Let me ask you something. So it just occurred to me as you and I were just talking. So we're getting evidence that Mars is really heating up very fast. Do you think that they're making potential plans for the evolution of that planet to continue to heat up? And now you're starting getting up into the range of, where you have temperatures that they can't breathe, but, the temperatures will be not these extreme colds.
Yeah, that's true. Eventually, though, the planet will lose its atmosphere, whatever electrons it has left, and then the stellar cores will basically lose interest in it. So it will be left like a moon.
I swear these things sound like vampires.
So I think that may be what happens. But in the meantime, its surface will be broken up by fissures. There may be volcanic eruptions because of these objects closely approaching. It's the same thing that is happening to Earth.
Yeah, and it's evidence. Well, Dr. Albers, another fascinating show. Thank you. You're a smart woman.
Thank you. Thank you.
You're a smart lady. As they would
Yeah, I
say.
mean, I try to think logically about all the things that I observe. You know, I'm still putting things together.
Yeah.
But today I finally reached the conclusion. I mean, I realized what they understood then.
You know,
That you cannot survive on the surface of this planet. They're going to destroy the surface. These objects.
You know, we've got the stories now of the first Adam and Eve and some kind of life eliminating event that happened. And it makes me wonder more and more, is our knowledge just not broad enough that we see the bigger picture? Because it seems like the solar system, our quadrant of space, is still the Wild West. I mean, it's crazy out there. I don't think we understand it yet.
The thing is, our knowledge of the universe and Earth and life and the real forces in the universe has been blocked for thousands of years.
Yeah. I know what I wanted to talk to you.
Many lies that take us in the wrong direction. Sorry.
Claudia, did you know that in the year 538, that Europe, Asia, the whole region there, Claudia, did you know that the sun was blocked out for 18 months?
Yeah, I've heard about.
I'm going to pull the story up while you're talking.
Something happened to produce the Dark Ages.
Yeah, I'm going to pull
it. Have been stellar cores coming to the Earth. Yeah, comets, because comets have been affecting the solar system for thousands of years.
Yeah, I want to pull this up for you because I did not truly know this. Yes.
Apparently, it didn't get blocked out completely, but it did get very dim. I mean, a volcanic eruption could have done that as well.
Mm-hmm.
A huge volcanic eruption could cause that.
Yeah, and I'm trying to pull it up on the exact...
But it could have been comets and all that dust coming through the atmosphere. But the thing is, the dust does not stay in the atmosphere indefinitely. It comes down.
I am going to pull this up because this was a fascinating study that they did here, and I did not realize it, that how bad it really was. Again,
yeah, you know, even our history, I don't know that if we know much about what actually happened in the past.
Yeah. Oh, here it is.
Because it's being hidden so much. And I mean, even if we are told something now, do we really know it's the truth? We're not sure. We cannot be sure.
You know, I've been a buff of history all my life. I don't remember being taught this. And so here's the story, 536. And here is what happened. It started when a mysterious fog swept over the continent, veiling the sun in a blue haze and casting Europe, the Middle East, and parts of Asia into darkness 24 hours a day for 18 months. Claudia, I never heard this.
I've never heard this before. That's why you know, this is very strange.
Oh, here it is.
Take this with a pinch of salt, unless there is other evidence that points to it.
Well, they said they have. That's what this whole article is about. But in all of my...
But then it should have surfaced long ago, and it never has.
I never heard of it. And
no.
Of course,
I mean, there have been people that have been digging into the history books and coming up with the truth for hundreds of years, at least 100 years, and they've never come up with something like this.
Well, that's, you know, is with the viewers.
But it's a possibility because the comets have been coming to Earth for thousands of years.
Yeah, I mean.
So it's just that they've never actually affected the sun like we see it's been affected now, because over thousands of years, this material is just accumulated in the sun's corona. We could clearly see it in the 1986 image.
Obviously. Well, it gives me... Go ahead.
Sorry, no, it's definitely a possibility. I mean, people were very afraid of comets in ancient times.
Yeah, they
because
were.
lots of horrible things would happen whenever a comet came into the solar system. It used to affect the Earth. There used to be material coming in, and people said that it caused disease.
Well, and that's what happened. The bubonic plague came after that. Wow. Well, Dr. Albers, thank you, ma'am. It has been fabulous.
Thank
And
you.
I
Yeah.
just want to thank everybody. Thank you, all the moderators. I didn't know that Scott's in here. Hello, Scott. And what I tell you, I walk away from these and, I marvel because it's accumulated knowledge.
Yes.
You learn, and you're a good teacher, Claudia.
Thank you.
You are.
I try,
You succeed.
Thank you.
That means that you have succeeded at trying, and that's
okay, good.
good. And I just thank you. I just want to thank our audience. I just want to speak favor over everyone's lives. Thank you for enriching Dr. Albers and my life with your presence, and continue to send your pictures. I send as much as I can to Dr. Albers. I don't try to overwhelm her, but next week I do want to pull some pictures that have been sent in by the viewers, and they've got some pretty strange pictures out there.
Oh, yes. The world's getting very, very strange, isn't it?
It is. All right. Well, thank you all. Y'all be good to yourselves. We'll see you next Monday night. Dr. Albers,